Hello everyone, this is Scott at International Rating at the headquarters here in Chesterfield, Michigan. In today's tech session, we're going to talk about the DTH and DTH-S heater made by the Reverber model made by Detroit Radiant. Specifically, it's going to be the 40 to 100,000 BTU models. They do make 125 and 150,000 BTU models, which are built entirely different. So we're going to focus on the 40 to 100,000 BTU models. So for starters, we're going to go over a quick sequence of operation. For that, I'm going to take the lid off. And so again, this is if the heater's running properly. So when the heater, this is called a line voltage heater. So if we have 120 volts that comes to the heater, the very first thing that you should hear is the fan would come on. If you don't hear this fan come on and there's 120 volts, pretty much that tells you right there to start with replacing the fan. From there, this is normally open switch would, once this box chamber here pressurizes, this switch would close. And if everything's running properly, the power would continue on to the normally closed switch. And that switch would actually stay closed unless there's a problem such as a bird's nest or a soot or a blockage typically in the radiant pipe or the exhaust tube. So this switch would stay closed, and then your power continues on there's a bimetal switch here on the side. That's actually a normally closed switch, so your power would go through that switch and then on to your hot surface igniter or a glow bar, and after about 20 or 30 seconds, that would actually, you would see that start to glow orange. And that would actually, there's a sight glass on the side of the heater, which you can't see here, but we'll show you a little video clip of that. You can see that typically from the floor or from your ladder or your service lift. So once that starts to glow, it'll glow for maybe 10 or 15 seconds. And when it gets hot enough, what it actually does is it actually opens up this bimetal radiant sensor. It goes from normally closed to normally open, and then it simultaneously takes the glow bar out of the circuit, but it puts the main solenoid of the gas valve in the circuit. And then there's a flame, you should have a flame, and then the heat from the flame is actually what will keep that radiant sensor in the open position, and the heater should continue to run until the call for heat is over. 120 volt power is removed from the heater, and then the heater will shut down. So let's start some of the troubleshooting techniques here. So very, very important. A lot of times people will get up to this heater and they want to start troubleshooting, you know, if this pressure switch is not closing or what have you. It's very important to inspect the external variables. You have an air intake to the heater, and sometimes there's an air intake pipe that's hooked up to that, especially if it's a dirty environment or a car wash or a high moisture environment. So it's important to inspect this for blockage at the screen, but also blockage for bird's nests or any other type of obstruction along the way of your intake pipe. Also, very important is to inspect the radiant tube. Now, right here on my table, I have just simply the power head. Typically, there's 20 or 30 or 40 feet of radiant pipe hooked up to this tube here, and sometimes that would have a bird's nest in the exhaust pipe, or maybe soot if it's a really old heater, soot accumulation. And so you want to check for those things before you get too far along in your troubleshooting process. So the first thing that we normally do, and this is a very unique heater, this heater does often require the lid being put back on and off during the troubleshoot process, whereas some of the later models, the newer models, you don't have to do that. So for starters, let's just say we've already confirmed that our fan does come on. So I have my power shut off. I would put my alligator clips across the two terminals on the air-proofing switch, the normally open switch. This is normally the culprit. If you do have one of these two switches to go bad, it's normally this one here in the blower compartment, known as the normally open switch. So we would put our alligator clips, put the lid back on, and you see I've already taken the liberty of removing my 1/4-inch screws from the lid. So for troubleshooting sake, power the heater. You could just hold the lid on and see, you can wait your 20 or 30 seconds, see if you get your orange glow. And if you do, whereas you didn't before, then we're going to focus in on that switch being the culprit, or again, there's some kind of obstruction on the intake of the heater. So let's just say we put our jumpers on that pressure switch and still no glow bar. The next step is to do the very same thing with this normally closed switch. You already get the picture on how to do that, so I'm not going to go through that process again. But you would put your jumpers on across the two terminals on your normally closed switch. So from here, typically what I do is, if I'm not getting a glow bar at this point, I would check the glow bar itself. Okay, so the glow bar, it's hard to see. Here's the connector for it. And then here, if I were to take that gas valve out and pull this burner out, this is what it looks like. That's the hot surface igniter or the glow bar. And so you could actually do a couple things. You could take an ohm reading on this hot surface igniter. Let me give you a fresh one here and show you an example. You take your, put your voltmeter on an ohm reading, and if this glow bar is intact, no cracks, a lot of times you can visually inspect these, and sometimes they have a little short in the glow bar. But if an operating glow bar, a good glow bar should have between 50 and 400 ohms. So if that checks out good, and so we would move on to our radiant sensor as the next item that could be of issue. So the radiant sensor, sometimes it'll fail in the actual closed position. And that would, if somebody were to describe to us that the glow bar stays on continuously and it never switches over to the gas valve, that would tell us that that radiant sensor is just stuck closed. It's just old, stuck. So right then, we would look to switch that radiant sensor out. But now let's say the glow bar still never comes on after jumping these other devices out. Maybe that radiant sensor failed in the open position. So what a lot of service technicians will do is they'll take their alligator clips and they'll jump it across the two terminals on the radiant sensor. And you have 120 volts there, so you do have to be careful. But sometimes they'll remove the power off one of the, if the glow bar does come on, finally, after doing that, they'll let the glow bar heat up for 10 to 15 seconds. They'll take the power off one of the terminals to simulate open. And if now everything magically works, that tells you that radiant sensor is probably the culprit. Let's say we've tried all that. And now the very last thing we have to check is the actual gas valve itself. And so you can take an ohm reading across the coils of the gas valve. And so what I'm going to do is I'm going to show you on a brand new gas valve out of the box. Okay, so actually it's very important though, you have to isolate all the wires on the valve. So you have to disconnect your hot surface igniter on the valve. You have to disconnect, you have wires coming in from your radiant sensor, you have wires coming in from your pressure switch. So you have essentially 4 wires that belong to this valve out of the box. You really should never have, there's some clear wire nuts on this valve that come from the factory. You should never have to cut these wire nuts off, and you should never have to check anything inside of these. So if we have a good valve, we would take a reading across the red and the black wire. So if we have a reading, again, everything has to be isolated. All the wires have to be on their own. If we have a reading between 610 and about 740 ohms, that tells us that this valve should be good. If we have a reading between 1100 and 1600 ohms, that tells us that this has a bad coil. If this has a bad coil, that's bad luck for you, because that valve is no longer in circulation. So you'd have to give us a call, or you could go to our website. We do have a replacement kit, which does now involve a new style valve and a circuit board and a whole heater rewire. So because this model heater is so old, what a lot of times will happen is people will actually replace this whole power head with a brand new power head once they factor in the cost and the labor and everything else. What we call a plug and play. We have a modern day power head known as our DX3L that you could essentially take this power head off and put that in its place, and you have a brand new heater. That concludes today's tech session, and we thank you for your time.